NASA faces the moon's deadliest hazards head-on with groundbreaking technology. From razor-sharp dust that clogs suits and instruments to unpredictable quakes that can shake habitats to their core, survival is no longer left to luck. Artemis 4 brings two revolutionary instruments, designed not to explore, but to protect astronauts. These systems turn the moon from a lethal wasteland into a manageable, even teachable, environment for humanity's next giant leap. The killers we ignored. The Apollo missions are remembered as heroic, clean victories. Rockets launched, flags were planted, and astronauts returned home as legends. But the truth beneath that story is much harsher. The Apollo crews survived because they stayed on the moon for only brief moments. Their missions were measured in hours and a few days, not weeks. They escaped because they did not stay long enough for the moon to fully reveal its dangers. Their success was built on courage, discipline, and a great deal of luck, not because the lunar surface was ever safe. The biggest danger they underestimated was the dust. Lunar regolith looks soft and powdery in photos, but up close it is one of the most hostile materials ever encountered by human explorers. On Earth, soil is shaped by wind and weather. Over time its edges soften. The moon has no air and no rain. There is nothing to smooth its surface. Every grain is created by unending meteorite strikes that break rock into tiny glass-like shards. They remain sharp forever. These particles cut into suit layers, scratched visors, and clogged every moving part. Once they stuck to a surface, they refused to fall off. Solar radiation charged them like static, causing them to cling to fabric, metal, and even skin. After his voyage to the moon's surface during Apollo 17, astronaut Gene Cernan acknowledged the challenge that lunar dust presents to long-term lunar exploration. Apollo 17 proved just how destructive this material could be. It was the longest lunar stay of the entire program, and even during those few days the astronauts saw their equipment wear down at an alarming rate. Suit joints stiffened until they squeaked with every motion. Gloves became so abraded that the fingertips showed signs of tearing. Boots lost multiple protective layers. Dust crept into latches and seals, causing small leaks in the vacuum systems. When the crew returned to the lander, the dust came with them. Inside the cabin it floated in the air and irritated their eyes and lungs. They described the experience as painful and inflaming, something they later called lunar hay fever. Then there was the second danger almost no one expected. The Apollo seismometers recorded moonquakes that lasted far longer than any quake on Earth. Some rang through the crust for nearly an hour. The moon's dry interior and lack of atmosphere allowed seismic waves to travel without losing energy. For astronauts living on the surface for weeks, these quakes could shift equipment, crack foundations, and destabilize habitats. All of these threats remained manageable only because Apollo crews left quickly. Most recently, NASA has selected two science instruments designed for astronauts to deploy on the surface of the moon during the Artemis 4 mission to the lunar South Polar region. Experts fear that Artemis 4 will not have that luxury. Its astronauts must live and work on the surface continuously. Their gear must endure constant dust abrasion and ground shaking, not just survive short encounters. Humanity is returning with bigger dreams and the moon is waiting with the same old traps, only now our blind spots could be fatal. When exploration turns into engineering for survival. Artemis is not a replay of Apollo. It is the beginning of something far more demanding. Apollo touched the surface and left. Artemis 4 will arrive with a plan to build, assemble, repair, and live in a place that does not want humans to stay. Its mission includes putting pieces of the lunar gateway together, operating on the surface for several weeks, running constant EVA cycles, and using heavy equipment that must survive the harshest environment any human crew has ever worked in. This is no longer exploration for a photograph. It is construction in a world that attacks everything you bring with you. The longer astronauts stay, the more the moon fights back. Dust that once only caused temporary problems during Apollo will become a constant, grinding force. It will work its way into every hinge, every joint, and every glove seam. Then there is the repeated thermal stress. The moon has no air, so temperatures swing violently between light and darkness. Metal expands in the heat and contracts in the cold. Over many cycles, This creates small cracks that grow into structural faults. Habitat walls, power cables, rover armor, and even the bolts holding equipment together face slow but relentless fatigue. What survives one day may fail on day 15. The choice of landing at the South Pole makes the risks even sharper. The regolith here is even more dangerous than at the Apollo sites. Since sunlight barely reaches the South Pole, the grains do not undergo the slow solar weathering found elsewhere. They are sharper, more jagged, and more destructive. At NASA, the message became clear. Apollo-style guesswork would not work anymore. If humans wanted to stay on the moon safely, they needed precise real-time information about dust storms, surface charge, ground motion, temperature shifts, and structural threats. That need led to two of the most important instruments ever built for human survival Earth. Machines designed not to explore the moon but to protect us from it. The machine that watches the deadliest dust in the solar system. To deal with the issue of lunar dust, scientists have developed a machine named DUSTER, which stands for Dust Sensing for the Lunar Surface Environment. This is a machine whose only job is to watch this deadly dust before it strikes. In a world with no air, no wind, and no mercy, DUSTER becomes the shield humans desperately need. The moment the sun rises over the lunar horizon, something eerie happens. Sunlight hits the surface and charges the dust as if flipping a switch. Each tiny particle becomes electrostatically alive, gaining enough energy to lift off the ground. The dust doesn't just rise, it floats, drifts, and travels across the moon's surface for kilometers. It moves like a toxic fog you cannot see. A ghostly cloud of microscopic blades that can scratch visors, tear at spacesuits, and poison life support systems. Astronauts can't outrun it, and cameras can't always catch it. But DUSTER can. Deep inside this machine are sensors so sensitive they can trace the path of a single grain of dust. DUSTER measures the particle's speed, its trajectory, and even the exact electrical charge pulsing through it. It listens for the first sign of levitation, the earliest moment dust begins to stir. That moment is crucial, because early-stage movement often signals surface instability. If the dust rises too fast or too high, astronauts know danger is building long before they step outside. DUSTER also studies dust storms triggered by landing plumes. When a spacecraft touches down or lifts off, its powerful engines blast clouds of dust into the air. These storms are violent and unpredictable, capable of sandblasting metal and burying equipment. DUSTER maps every swirl and ripple of these storms, creating a real-time picture of how they grow, expand, and settle. To track the finest particles, the machine uses electric field sensing arrays, following grains so small they would slip through ordinary instruments. For humans on the moon, this information can mean the difference between safety and catastrophe. Dust warnings help prevent suit abrasion that could lead to deadly leaks. They stop filters from choking, protect mechanical parts from grinding themselves to failure, and keep long-term habitats from becoming contaminated. Most importantly, DUSTER helps mission control choose safe windows for spacewalks, giving astronauts precious time to act before conditions turn hostile. Yet even with all this protection, one truth remains unsettling. Dust is only half the danger, because the moon itself can move beneath your feet without warning, posing an even greater challenge. The moonquake sentinel built to guard a fragile habitat. On Earth, earthquakes roar, shake, and fade. On the moon, they echo. They travel through dry, rigid rock with nothing to soften their force. They build, rebound, and continue long after they should have ended. For astronauts living in fragile habitats far from home, this kind of shaking is a silent threat that could turn deadly. To tackle this issue, scientists have developed SPSS. The Seismic and Physical Science Suite is humanity's alarm system. On a world that never stops shifting beneath the surface. SPSS is built around two powerful sensing tools. Its seismometer is designed to catch the faintest tremble in the ground. From deep rumblings hundreds of kilometers below to sudden fractures just beneath the surface. Alongside it, the magnetometer listens for changes in the moon's magnetic environment, which can reveal hidden stresses inside the crust. Together, they form a watchful pair that records every vibration, every shift, every warning sign the moon gives. The Moon is not seismically dead. Far from it. Apollo missions left behind seismic instruments that worked from 1969 to 1977, and the data they collected changed everything. Scientists discovered 4 types of moonquakes, each with its own signature and threat. Deep moonquakes come from far below the surface, often tied to the Moon's constant tug-of-war with Earth's gravitational pull. Thermal moonquakes strike when the frozen crust suddenly warms at sunrise, expanding with enough force to crack rock. Shallow moonquakes occur only a few dozen kilometers down, and they are the most dangerous. As the Moon continues to cool and shrink, its surface buckles and slips along thrust faults. These shallow quakes can reach magnitudes similar to strong quakes on Earth, enough to move boulders or damage structures. Then there are meteoroid impact quakes, created when even small space rocks slam into the surface. SPSS listens for all of them. It measures the strength and length of every quake in real time. It monitors how a habitat's walls or foundation respond, giving engineers the data they need to reinforce weak points before they fail. By mapping vibrations through the ground, SPSS can even predict when slopes might collapse, or when regolith could shift beneath a landing pad. Over months and years, it builds a detailed seismic map so future bases can be placed in safer, more stable regions. The danger is not just that moonquakes are strong. It is that they last far longer than those on Earth. Some have continued for 10 minutes, and others may have echoed for hours in the dry lunar crust. Without atmosphere or water to absorb the shaking, the Moon rings like a bell, carrying the tremors across great distances. For a habitat built on unfamiliar ground, this kind of endurance shaking could crack supports, loosen foundations, or destabilize equipment meant to last for decades. With Duster watching above and SPSS listening below, NASA is sending Artemis 4 to understand the Moon not as a destination but as a proving ground for something far more ambitious. The South Pole Laboratory. The Moon's South Pole is emerging as the centerpiece of NASA's Artemis program, offering unique conditions that make it ideal for a long-term human presence. Unlike the equatorial regions explored during the Apollo missions, the South Pole hosts permanently shadowed regions, PSRs, craters that never see sunlight. These shadowed craters maintain extreme cold, preserving water ice and other volatile compounds for potentially billions of years. Water ice is a crucial resource. It can be used for drinking, converted into breathable oxygen, or split into hydrogen and oxygen to create rocket fuel. This combination of ice-rich craters and nearby elevated regions that receive near-constant sunlight presents a perfect balance of energy and resources for sustained operations. The Artemis South Pole Laboratory is more than a landing site. Please like and subscribe channel.